Hello everyone, and welcome to this video where I'll be reading through the OpenStax.org textbook called Prealgebra, and it's their second edition. In particular, I'll be reading through part of section 1.2, which is called Add Whole Numbers, and I'll go through the part of the section with the heading Add Whole Numbers Without Models. So here we are, OpenStax.org. Their Prealgebra second edition text, section 1.2, add whole numbers, pardon me. And I'm in the heading, add whole numbers without models. Now that we have used models to add numbers, we can move on to adding without models. Before we do that, make sure you know all the one-digit addition facts. You will need to use these number facts when you add larger numbers. So imagine filling in table 1.1 by adding each row number along the left side, each column number across the top. Make sure that you get each sum shown. If you have trouble, model it. It is important that you memorize any number facts that you do not already know, so that you can quickly and reliably use the number facts when you add larger numbers. So here's our single-digit addend table, single-digit addition table, table 1.1. So I will read through all of these, and you should get to know all of them by heart. Once again, if you are unclear about one, model them with your base 10 block, like you saw in the last video. So 0 plus 0 is 0. 0 plus 1 is 1. 0 plus 2 is 2. 0 plus 3 is 3. 0 plus 4 is 4. 0 plus 5 is 5. 0 plus 6 is 6. 0 plus 7 is 7. 0 plus 8 is 8. 0 plus 9 is 9. Now to the 1 row. 1 plus 0 is 1. 1 plus 1 is 2. 1 plus 2 is 3. 1 plus 3 is 4. 1 plus 4 is 5. 1 plus 5 is 6. 1 plus 6 is 7. 1 plus 7 is 8. 1 plus 8 is 9. And 1 plus 9 is 10. Now to the 2 row. 2 plus 0 is 2. 2 plus 1 is 3. 2 plus 2 is 4. 2 plus 3 is 5. 2 plus 4 is 6. 2 plus 5 is 7. 2 plus 6 is 8. 2 plus 7 is 9. 2 plus 8 is 10. And 2 plus 9 is 11. Now the 3 row. 3 plus 0 is 3. 3 plus 1 is 4. 3 plus 2 is 5. 3 plus 3 is 6. 3 plus 4 is 7. 3 plus 5 is 8. 3 plus 6 is 9. 3 plus 7 is 10. 3 plus 8 is 11. 3 plus 9 is 12. And now on to the 4 row. 4 plus 0 is 4. 4 plus 1 is 5. 4 plus 2 is 6. 4 plus 3 is 7. 4 plus 4 is 8. 4 plus 5 is 9. 4 plus 6 is 10. 4 plus 7 is 11. 4 plus 8 is 12. And 4 plus 9 is 13. Now the 5 row. 5 plus 0 is 5. 5 plus 1 is 6. 5 plus 2 is 7. 5 plus 3 is 8. 5 plus 4 is 9. 5 plus 5 is 10. 5 plus 6 is 11. 5 plus 7 is 12. 5 plus 8 is 13. And 5 plus 9 is 14. Now the 6 row. 6 plus 0 is 6. 6 plus 1 is 7. 6 plus 2 is 8. 6 plus 3 is 9. 6 plus 4 is 10. 6 plus 5 is 11. 6 plus 6 is 12. 6 plus 7 is 13. 6 plus 8 is 14. And 6 plus 9 is 15. Now the 7 row. 7 plus 0 is 7. 7 plus 1 is 8. 7 plus 2 is 9. 7 plus 3 is 10. 7 plus 4 is 11. 7 plus 5 is 12. 7 plus 6 is 13. 7 plus 7 is 14. 7 plus 8 is 15. And 7 plus 7 plus 9 is 16. Now for the 8 row, 8 plus 0 is 8. 8 plus 1 is 9. 8 plus 2 is 10. 8 plus 3 is 11. 8 plus 4 is 12. 8 plus 5 is 13. 8 plus 6 is 14. 8 plus 7 is 15. 8 plus 8 is 16. And 8 plus 9 is 17. And then the final row here, in row 9, 9 plus 0 is 9. 9 plus 1 is 10. 9 plus 2 is 11. 9 plus 3 is 12. 9 plus 4 is 13. 9 plus 5 is 14. 9 plus 6 is 15. 9 plus 7 is 16. 9 plus 8 is 17. And finally, 9 plus 9 is 18. So as they were saying, please learn these addition facts. If you know how to sum the single digit addends, 0 plus 0 up to 9 plus 9, you have all the tools you'll need to do addition of any whole numbers, no matter what size and no matter how many digits they have, as we'll see later. So, did you notice what happens when you add 0 to a number? The sum of any number and 0 is the number itself. We call this the identity property of addition. 0 is called the additive identity. So here is the identity property of addition. The sum of any number a and 0 is the number a itself. And they demonstrate that in both orders. A plus 0 is equal to a. 0 plus a is equal to a. All right. So for example, 1.15, we're asked to, find each sum. So I'll go to some paper. So again, this is example 1.15, part A. So the first sum is 0 plus 11. So again, the properties, this is that identity property of addition that is being applied here. The identity property of addition. So I'll write it up here again. We have, so 0 plus any number, right? A can represent any number, will equal just that number again. And the same goes in the other order. If I take any number a plus 0, we're going to get that number back again, a plus 0. So if I have, 11 blocks and I add to it 0 blocks, that doesn't change the number of blocks. You still have 11 blocks if we were using our models. So 0 plus 11 is 11. In part B, another sum where 0 is one of the addends. 42 plus 0. Once again, if 0 is one of the parts of the sum, is one of the addends, then you just end up with the other number. That's not 0. Right? 42 plus 0, if I have 42 blocks, and I add no blocks, 0 blocks, you still have 42 blocks, right? So the sum of 42 and 0 is still 42. Okay. Easy enough, I hope. And with the examples, remember you can check your solution in the text to show solution. So again, one of the addends is 0. The sum of any number and 0 is that number itself. So 0 plus 11 is 11. 42 plus 0 is 42. Excellent. All right. And then we're doing the same for these try it problems. Again, these should be very quick. All right, when we're adding 0, when one of the addends is 0, a number keeps its identity, right? It stays the same. Thus the name identity property. All right, so try it 1.29, part A, and very simple, 0 plus 19 is just 19. Easy. Part B, 39 plus 0. Once again, one of the addends is 0, so we keep the other number. Nothing changes. The 39 stays 39. 39 plus 0 is 39. And that's that for try it 1.29. 19 and 39. And I've mentioned this in previous videos. If you want to check yourself, check your answers for these try it problems in the text, you open up the table of contents, go to the answer key, and we are still in chapter 1. Now these are not the be prepared problems, these are the try it problems, and that was try it 1.29. And you see 19 and 39, like we had. Great. and then I click on the number, it takes me right back to the reading, try at 1.29. All right, so I'll do the same thing for try at 1.30. So again, I have enough room here. These are pretty short problems. Right, hopefully you're seeing how very simple it is to add when one of the numbers, one of the addends is 0. So try at 130, right? Part A. What's the sum of 0 and 24? Well, that would just be 24. Easy. Part B. What is the sum of 57 and 0? Right? 57 plus 0. Well, that would just be 57. Very, very simple in my opinion. So 24, 57. It never hurts to check, I mean, I know I'm pretty sure we're right, but let me go back to the chapter 1 answer key, try at 130, and 24 and 57 are indeed correct. Okay, click on 130, takes me right back to the reading. All right. So now they're saying, look at the pairs of sums in the following chart. So you see how 2 plus 3 is 5, but also, 3 plus 2 is 5. Here in the second row, 4 plus 7 is 11, but also 7 plus 4 is 11. And you can always refer back to this table up here with your single digit addends if you're unclear, but get to knowing those, memorize those, know them well. Then third row, 8 plus 9 is 17, but so is 9 plus 8. 9 plus 8 is also equal to 17. So notice that when the order of the addends is reversed, the sum does not change. This property is called the commutative property of addition, which states that changing the order of the addends does not change their sum. So here is the commutative property of addition. Changing the order of the addends, say A and B, does not change their sum. So that means A plus B equals B plus A. The sum of A and B is exactly the same as the sum of B and A, right? You get the same number of blocks if you were modeling both sums. Okay. So example 1.16. Go to some paper here. Some pretty simple single digit addends in this example. So this is example 1.16. We're asked to add, right? Find the sum. Part A, you have 8 plus 7, right? You have 8, if I was modeling, I'd have 8 blocks, add 7 blocks, and then there'd be 10 blocks I'd replace with a tens rod, so I have 110 with 5 blocks left over for the 5 single blocks. This is 15. 8 plus 7 is 15. Once again, you shouldn't, after enough practice, you shouldn't have to model with blocks. You could just know these single digit sums, right, from that table, table 1.1 earlier that I read off. And then part B is what is, 7 plus 8. So again, what we're applying here is called the commutative property of addition. Commutative. And it was simply that if you take A plus B, you'll get exactly the same sum as if you switch the order of the addends, b plus a. So here I have 8 plus 7 in this order. 8 comes first, 7 comes second. I got a sum of 15. Well, what we're being told, this commutative property of addition says that 7 plus 8, right, should be exactly the same as 8 plus 7, right? Switching the order of the addends shouldn't matter. And either way, you're getting a sum of 15, right? And that's all. So both of those should be, 15. And again, with the examples, you can see the solutions right away. So you see 8 plus 7, 15. 7 plus 8, also 15, right? Did you notice that changing the order of the addends did not change their sum? We could have immediately known the sum from part B just by recognizing that the addends were the same as in part A, but in the reverse order. As a result, both sums are the same. That is, again, the commutative property of addition. Wonderful. All right, so I got a couple more try it problems that I'll put on the same page. And we'll check their answers again in the answer key. So the next one is try it, number 1.31. And we're asked to add 9 plus 7 and 7 plus 9. But those should be the same, according to this, commutative property of addition, right? 9 plus 7 should be equal to 7 plus 9. And no matter how you add those, you will end up with 16. That's 1 10 and 6 ones. 16 blocks. And that's it. That's 16 either way. I'll go to the answer key, chapter 1, try at 131, and see either one is 16. Great. All right, then try it 1.32, another application of this commutative property of addition. Try at 1.32. We're asked to add 8 plus 6 and 6 plus 8. But those have the same addends, just in the reverse order. So they should be the same, and they are the same. 8 and 6 is the same as 6 and 8. And 8 plus 6, 6 plus 8, both of those are 14. 1 10 and 4 ones. Double check. Back to the chapter 1 answer key, try at 1.32, and both sums are indeed 14. Wonderful. All right. All right, so now we get into adding addends that have more than one digit. So I'm actually going to model this first one. I know they called it adding without modeling. I'm going to model this first one and maybe one of the other ones later with some blocks, and then show you how they're going to have you, they suggest you do addition when there's more than a single digit in each of the addends. All right, so example 117, we're asked to add 28 plus 61. Right, so example 1.17, we're asked to take 28 plus 61. So with modeling, all right, again, I know that it was the heading of this is without modeling, but because this is the first time we're coming across these, 2-digit addends here, I'm going to model. All right. So 28, that's, 8 ones. All right, so I've got my 8 individual blocks It's 1, 2, 3, 4, 5, 6, 7. So here's 8 single block for the 8 ones. All right, it's 8 ones. And there are 2 tens, 2 in the tens place. Right, so I've got 2 of these 10 block rods, right? So that's 2 tens and 8 ones. That's 28. And then we're adding to this, plus, and then 61, right, has 1 in the ones place, so 1 individual block, and 6 in the tens place, right? So I've got 6, 3, 4, 5, 6 of these 10 blocks, right? That's 61. So we put them together, right? We're adding them together. So this will be equal to, well, you have, 1 and then, 8 more ones blocks. So you see how that's 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 1 plus 8, 9 in the ones place. So I'll write the 9 up here. We got 9 single blocks. And, again, I know I have the equals there. And you put the tens together. 1, 2, 3, 4, 5, 6, 7, 8, right? 2 plus 6, 2 tens and 6 tens makes 8 tens. So I have 8 in the tens place. So our sum, 28 plus 61, or, 61 plus 28, remember that commutative property, you can switch the order, it'll be the same sum, is 89. 8 tens, 9 ones. So notice what I described was we added the ones, 8 and 1 made the ones not the 9 in the ones place, and then we added the tens. I'll double underline those, 2 and 6, which adds up to 8. So 8 in the tens place, 9 in the ones place, 89 is our sum. All right, so that was with modeling. Now, without modeling, and all you're going to need to know how to do to add any whole numbers is know that table 1.1 from earlier. Know all of your single digit sums. 0 plus 0 up to 9 plus 9. Right, so let me get rid of the blocks here. All right, so without modeling, they're going to suggest you do this. You stack them. So I write 28, I write one of the addends, and then plus, I'll do it vertically, stack them. And then 61, and they'll have a little bar underneath for equals. And when you're doing this, make sure to line up decimal places, line up place values. Meaning, see, I've got the ones lined up, 8 ones and 1 1. And I've got the tens places lined up, 2 tens and 6 tens. And then you just add in the individual, add up the place values. 8 ones plus 1 1, that's 9 ones. So 8 plus 1 is 9 in the ones place. So again, I'll put that down here. This is the ones place, right? And then we add up, keep going to the right, to the left here, you add up the tens. 2 tens plus 6 tens. 2 plus 6 is 8. So there are 8 tens, 9 ones, right? The sum, as we said earlier when we were modeling, is 89. So you'd have 89 blocks if you were modeling like we saw. All right, and going back here, example, so we can see the solution right here. See how they stack them up? and line up the place values vertically, then you just add the digits in each place value. The ones add up to 9, the tens digits add up to 8. 89. Great. All right, so we're asked to do that again. So these two, the try it problems, I'm going to do without modeling, right? So without the blocks. Just lining up place values and adding up the individual digits in the place values, the single digits in the place values. Okay, so try it. 1.33. We're adding 32 plus 54. So you got 5 in the tens, 4 in the ones, and we're lining these up, all right? 2 in the ones, 4 in the ones, 3 in the tens, 5 in the tens, right? Line up the ones and tens, line up the place values. There are 2 ones and 4 ones. 2 plus 4 is 6. So it's 6 ones. And then there are 3 tens plus 5 tens. 3 plus 5 is 8. So there are 8 tens, 6 ones. The sum of 32 and 54 is 86. And that's it. All right, 86 blocks. Once again, I'll check it out. All right, go to the answer key, chapter 1, try it 1.33. And we get, 86. 32 plus 54. Excellent. All right, so then back here, try it 1.34, very similar, where we're stacking these up vertically, right? Lining up place values vertically. So try it 1.34. We're asked to add 25 plus 74. All right. So again, I stack them up like this. Ones place lined up, tens place lined up. 5 plus 4, 5 ones and 4 ones, that's 9. And tens place, 2 plus 7 is also 9. So 9 tens, 9 ones, that's 99 for the sum. Let's check it out. And I know I'm correct, but it never hurts to look. And you see 1.34, 99. Excellent. All right, so then they talk about, what happens when I line up these place values and the sum is bigger than 10, 10 or more. So far, we've seen sums of digits in place values that were under 10. So in the previous example, the sum of the ones and the sum of the tens were both less than 10. But what happens if the sum is 10 or more? So this is where they're going back to modeling with the blocks, right? Let's use our base 10 model, the blocks, to find out. Figure 1.10 shows the addition of 17 and 26 again. So see 17 up top plus 26. So you see there's 1 10 and 7 ones blocks for 17. And then 26 has 2 tens rods, and 6 ones. When you put those together, there are 3 tens. All right, there's 3 tens and 7 ones and 6 ones. 7 and 6, it's 13, which is another 10 and 3 ones. So they move 10 of these, they exchanged 10 of the individual blocks for another tens rod, leaving you with 3 ones in the ones place. So they're going to denote that exchanging by putting another 10 above the tens column. You see the little red 1 here. And then you got 4 tens and 3 ones when you're all done, 43. So yeah, when we add the ones, 7 plus 6, we get 13 ones. Because we have more than 10 ones, we can exchange 10 of the ones for one 10, right? One of those tens rods. Now we have 4 tens and 3 ones. Without using the model, we show this as a small red 1 above the tens place, the digits in the tens place, indicating that we've exchanged for a 10. When the sum in a place value column is greater than 9, we carry over to the next column to the left. Carrying is the same as regrouping by exchanging. For example, 10 ones for 1 10, or 10 tens for 100, and so on. 10 hundreds for 1,000, and so on. All right, so a little how-to box here. How to add whole numbers. So step 1, write the numbers so each place value lines up vertically. Step 2, add the digits in each place value, working from right to left, starting with the ones place. If a sum in a place value is more than 9, carry to the next place value. Right? You're going to be doing exchanging for one block or one rod or one square in the next higher place value. Step 3, continue adding each place value from right to left, adding each place value and carrying if needed. All right, so just one more time, I'm going to bring back modeling. All right, so with the blocks, and this will be the last time I model. And then the rest for this video. And then the rest of the addition we'll do is going to be without modeling and this, carrying procedure if we need to. So example 1.18, we're asked to add, 43 and 69, 43 plus 69. So example 1.18, we have 43, and I'll do it with the modeling first, right? So first with models, with the blocks, 43 plus, 69. So 43, right, bringing these back. So we have 3 ones, right, so three individual blocks, right, 3 ones, and there are 4 tens, right, 4 tens, so 4 of these 10 block rods. All right, so there's 43 blocks modeled with these blocks. All right. And we're adding to that, 69. So that has 9 in the ones place. So there's 3, 6, 9 individual blocks, 9 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9. Great. And then 6 tens. So 6 of these tens rods. All right, 1, 2, 3, 4, 5, 6. All right, so there is the modeled 69. 6 tens, 9 ones. All right. So we're going to put them together, and I'll do it in the order that they were talking about. So we'll put the ones together. So I got 9 ones. All right, so this will be equals. And 3 ones. So you see that's 12, 9, 10, 11, 12. That's 12 ones. That's more than 9. So we're going to do an exchange, right? And this will be the carrying later when I do it without modeling. So you see I've got 10 ones right here. 10 ones with 2 left over. That's 12. Now, unfortunately, wow, okay. I'm out of 10s rods. Well, darn. Only 10 of them came in the box. Anyway, well, okay, so imagine, so I'll try to stick these together as best I can. I'm not going to glue them or anything, but so this is a 10s rod now. This is going to be a 10. All right, so let's try to keep them together. So that'll represent that. So that's a 10s rod. Just imagine that that's one of these green rods here. I'm sorry. All right. So now I have 2 ones, and then I, made another 10 because there were 12 total ones. I made 1 10 and 2 ones. And then when we count all the 10s, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 10s and then another 10. Anytime there's 10 of something, we'll make an exchange. We'll do some carrying. So there's still a 1 10 left over. So there's going to be 2 in the ones, and there'll still be one 10, but there were these 11 10s. I'll keep one, and then I exchange these 10 10s for, this is a 100 block, 100 square. All right, this is 100. See how it matches up? So I exchange that for 100. That's a 100 block. So going one step at a time again, 9 plus 3 was 12. So what I have is, again, we have 2 in the ones, and then I carried 1 10 over. I exchanged for a 10. And then so what they're going to do is they're going to put, I'll make it red like they did. So I throw another 1 10 in the 10s place, and then, 4 and 6 was 10, and then another one is 11. We had 11 10s, which I kept one of those. And then exchange 10 of them for 100. So I put one. Now I know there's no 100 spots here, but I'll put another red 1 in the hundreds place. And then we have 100 and no hundreds, right? So there's 100, 110, and 2 ones. 112 is our sum. 100, 110, 2 ones after I'm done with all the exchanging, all the carrying. All right, so that's with modeling, with blocks and everything. So let me get rid of these, and I'll do the same without the models, without the block. All right, so without the models, and we're taking 43, going to add to that 69. And I'm writing them vertically, lining up the correct place values. And starting from the right, I'm going through that procedure, that little how-to box they described. 3, and again, this is where knowing all those single-digit sums from table 1.1 will come in handy. 3 plus 9 is 12, okay? So I'd have 12 is 2 ones and 1 10. So this is the carrying part, right? 3 plus 9 is 12, but 12 is, 2 ones and 1 10. Right, so I move a 1 over to the tens place. Right, then we add up all these tens digits. That's the carrying. Right, then we add up all the tens digits. 1 plus 4 is 5, plus 6 is 11. Right, or 10 plus 1 is 11. So again, 11 is 1 in this spot, and then I carry another 1. 11 tens is 1 10, and 10 tens, which is 100. So I put a 1 in the hundreds place, right? So now we have a hundreds place. And then all that's in this hundreds place is this 1, so that's just 1. And we get the same sum as earlier, 112. 100, 110, 2 ones. Okay. Again, this is an example, so I can see their solution. So I stack them up. All right. 3 plus 9 is 12, which is, 2 ones and 1 10. Then 1 plus 4 plus 6 is 11. 11 tens is 110 and 100, right? And they throw the... Now they just wrote 11 in the sum because you're at the end. Because I guess at the end, you can just write at the far left, you can just write the sum at the end because, the carrying over, there's nothing in the place to the left of that, so there's no reason to carry over, but I'm going to still do the carrying over. All right. All right, so then you have these try-it problems that are very similar. So again, I'm going to go into these and we'll check them in the answer key when we're finished. But now I'm just going to do all the rest of these sums. All right, I'm going to do without modeling, just lining up the place values vertically and going from right to left, starting from the ones place, adding up the digits in the place values, and carrying to the next place value whenever the sum is 10 or more. Okay, so the next try it problem. Let's just try it 1.35. That's to add, right, 35 plus 98. And lining up ones, lining up tens. All right, so 5, starting from the ones place. 5 plus 8 is 13. 13 is 3 ones and 1 10. So I move carry a 1 to the tens place. Then we add up all the digits in the tens place. 1 plus 3 is 4. And then 4 plus 9 is 13. Now 13 tens is 3 tens and 100. Right, so I put a 1 in the hundreds place, and that's the only number in the hundreds place, so there's a 100. So 35 plus 98 is 133. And that's it. It's really that simple. Again, if you know all your single-digit sums from table 1.1 earlier, that should make this very, very easy. And once again, let's check it out. It never hurts to check. Answer key, chapter 1, try it, problems 1.35, 133. Excellent. All right, and go back. All right, try it, 1.36. Another sum. All right, we're all adding in this section. Add 72 plus 89. Again, lining up ones and tens, right? Lining up common place values. Starting from the right in the ones, 2 plus 9 is 11. 11 is 1 1 with 1 10 left over, right? So 1 1 and 1 10. So I put a carry a 1 in the tens place, and then add these up. 1 plus 7 is 8, and then plus 8, 8 plus 8 is 16. Now 16 tens is 6 tens and 100. So I put a 1 in the hundreds place, and that's the only number in the hundreds place, so I bring it down. Right, that's 161. 100, 6 tens, 1 1. Right, let's check it. Let's try 1.36. 161. Excellent. All right, then the next example, they bump it up a bit. And you'll notice the rest of the examples and try-its are all just a bunch of adding. So they add just 2 addends for a while. So example 1.36. 19, you see that the addends both have now 3 digits in them. The same procedure holds, though. When we're adding two addends, we're going to stack up vertically the place values, line up the place values, and then start from the ones place and add. And anytime the sum is 10 or more, we'll do some carrying. Right. Okay, so example 1.19. I got enough room here. There's enough space on this paper. Example 1.19. We have 324. Right, so now there's a hundreds place. Plus, and then 586. So 5 in the hundreds, 8 in the tens, 6 in the ones. So line up the places. Starting from the ones place, right, the far right place here in the whole numbers. Add them up. 4 plus 6 is 10. Now 10 is 0 ones and 1 10. Right, so I move a 1 to the carry a 1 to the tens place. Then 1 plus 2 is 3. 3 plus 8 is 11. 11 tens would be 110, and now 100. I carry a 1 to the hundreds place. And then in the hundreds, 1 plus 3 is 4, and 4 plus 5 is 9. There's no carrying to be done. That's not 10 or more, that's 9 or less, right? So there we go. The sum of 324 and 586 is 910. And you can see the solution with the examples here. They go through all the carrying stuff, right? 900. And okay. All right, so then the next try it problem. Again, I still got some space here. The next try it problem, try it 1.37, is another one like this with the adding two 3-digit numbers. Whole numbers, you got 456 plus 376. All right, we gotta line up the place values. Starting at the ones, 6 plus 6 is 12. So I got 2 ones and 1 10. 1 plus 5 is 6. 6 plus 7 is 13. So you got 3 tens and 100. And then finally in the hundreds place, 1 and 4 is 5. 5 and 3 is 8. That's 8 hundreds. Right? So this sum is 832. Let's check it out. Back to the chapter 1 answer key. Try at 1.37. 832. Wonderful. All right, then try it 1.38. Another sum of two 3-digit addends. The same procedure is going to continue here. So try it 1.38. Another sum of whole numbers, 269 plus 578. Line up the place values. Start at the right with the ones. 9 plus 8 is 17. So that's 7 ones and 1 10, right? So I'm carrying a 1 to the tens place. 1 plus 6 is 7. 7 plus 7 is 14. So 4 tens and 100. And then in the hundreds, 1 plus 2 is 3. 3 plus 5 is 8. That's 847 for that sum. And check it out. Let's just try it. 1.38. 847. Beautiful. All right, then the next example. Now they bump up, there's a 4-digit whole number plus a 3-digit whole number. The same procedure is going to continue. So in example, 1.20, we have a 4-digit number, 1,683, plus, and then a 3-digit whole number, 479, once again lining up the correct place values, ones with ones, tens with tens, hundreds with hundreds, and then now you have a thousands place. Right now there's a thousands place, but still the same procedure will continue. Starting at the ones place, 3 plus 9 is 12, so that's 2 ones and 1 10. Adding up the tens digits, 1 plus 8 is 9, 9 plus 7 is 16, so that's 6 tens and 100. Adding up the hundreds digits, 1 plus 6 is 7, 7 plus 4 is 11, so that's 100. And then the other 10 hundredths get exchanged for 1,000. So I carry a 1 over the thousands place, a comma between the periods here, and then the thousands place, 1 plus 1 is 2 there. So the sum is 2,162. Notice nothing really changed there, just the size of the numbers, just the number of digits, but the procedure was the same. Oh yeah, and that was an example. Was an example. I could just check it right there. All right, example 1.20. See, again, they go through adding from right to left, ones place to thousands place, 2,162. I do warn you, when the addends have different numbers of digits, be careful to line up the corresponding place values, starting with the ones and moving toward the left. Just be aware that when the addends have a different number of digits, just be careful when you're lining them up. Make sure you're lining them up properly. All right, so they got some try it problems that are very similar to this previous example. So now we're on try it 1.39. So another one where we have a 4-digit number, 4,597 plus 685, lining up all the correct place values. Starting at the ones, 7 plus 5 is 12, so that's 2 ones and 1 10. I carry the 1 to the tens place. Adding up the tens digits, 1 plus 9 is 10. All right, then 10 plus 8 will be 18. Now I know that was a 2-digit number plus a 1-digit number, but hopefully you're able to be confident enough to know what 10 plus 8 is, or you could go off to the side and be like, hey, 10 plus 8, and then do, 0 plus 8 is 8, and then 1 plus nothing is 1, that's 18. So if you need to go off to do some side work here with higher digit numbers, you can, if you're uncomfortable with more than 1 digit at a time. Anyway, 1 plus 9 is 10, and then again 10 plus 8 is 18. So this is 8 tens, and then 100. And then adding up the hundreds, 1 plus 5 is 6, 6 plus 6 is 12, so it's 2 hundreds and 1,000. All right, that's 10 hundreds would be exchanged for 1,000. Again, I got a comma here between the periods, and then the thousands place, 1 plus 4 is 5, right? So 5,282 for try it 1.39. Let me check that out. So 5,282. Excellent. All right, then try it 1.40. Still another 4-digit plus 3-digit. try it 1.40. So we have 5,837 plus 695. 695. Right, lining up the place values correctly. Starting with the ones, 7 plus 5 is 12, right? So that's 2 ones and 1 10. Carry the 1 in the tens place. Then the tens. 1 plus 3 is 4. 4 plus 9 is 13. So that's 13 tens. That's 3 tens and 100. Then in the hundreds place, 1 plus 8 is 9. 9 plus 6 is 15. So that's 5 hundreds and 1,000. And then 1 plus 5 is 6. You got 6,000. 6,532 is that sum. Check it again. Try it 1.40. 6,532. Excellent. All right, so then the last few things, the last example and couple try it problems, so far we have been adding 2 addends at a time. You'll notice that in these last 3 sums here, there are 2 plus signs, so 3 addends. And I'll show you multiple ways we can approach it. So far we're comfortable with adding 2 addends at a time. So if you want, you can always do this. You can always take 2 at a time as you go from left to right. So let me show you what I mean. So in example 1.21, we're given the following, 21,357, plus 861 plus, and then 8,596. So I'll call the first thing I'm doing method 1, where you just add 2 at a time. 2 addends at a time. And there is absolutely nothing wrong with this. It just might take a little longer. So from left to right, the first 2 addends, the first 2 numbers being added are these 2. I'll take this down here. We'll do 21,357 and then add to this the 861. Lining up the place values, the correct place values, and then starting with the ones. 7 plus 1 is 8. There's no carrying, that's not 10 or more. Then the tens place, 5 plus 6 is 11. So that's 110 with 100. 10 tens for 100. Then the hundreds place, 1 plus 3 is 4. 4 plus 8 is 12. So that's 2 hundreds and then 1,000. And then in the thousands place, 1 plus 1 is 2. No carrying. And then in the 10, now we have the 10,000s place. There's, just 2 plus nothing. All right. So these first 2 addends add up to 22,218. And then we can add the next addend, right? So I'm going to put this, what you'll see people doing is just stack it on. I added these first 2, got 22,218. So now we have 22,218 plus the next addend, plus, and then the next addend is 8,000. So again, lining up the thousands, 8,596. We add those, just like I was doing. Now maybe I should have left a little space here, but when we do the carrying, but hopefully you can see my red pen. So starting from the ones, 8 plus 6 is 14. So that's 4 ones and 1. There's a 1 there, 110. Then 1 and 1 is 2. 2 and 9 is 11. So the 110 and 100, another 1 up here above the hundreds. 1 and 2 is 3, 3 and 5 is 8. So that's 8, no carrying, right? That's not larger than, that's not 10 or more. So no carrying. Then in the thousands place, 2 plus 8 is 10. So that's 0 thousands. And then 10 thousands will be 1 10,000. Right? 0 thousands and 1 10,000. So this 1 goes above the 10 thousands. And then the 10 thousands digits add up to 3. 1 plus 2 is 3. And there's our final sum. 30,814. All right. Now, that's one way to do it. Go 2 at a time from left to right as you add. Add the first 2, gives me that. And then take that 22,218, add the next addend, which we just did, got 30,814. Now the other method is just stack all the addends. All right, now this is definitely for people who are more confident with their ability to add. Because if you stack multiple, more than 2 addends in one sum, there's a good chance your sums will be larger than, the 10s. They might add up to the 20s or 30s. So just be careful with what you're carrying. So for this one, I got, 21,357 plus, put the big plus at the bottom here. We're just adding all these things. 861. So again, lining up the place values. Plus, and then 8,596. And again, this is for people who have much more confidence in their ability to add strings of numbers. So again, with the plus down here implies that we're adding all of these. This is all addition. So, starting with the ones place. 7 plus 1 is 8. 8 plus 6 is 14. So I have 4 ones, and then I put 1 above the tens digits. All right. Then the tens. 1 plus 5 is 6. 6 plus 6 is 12. And then 12 plus 9. Now I know one of those is 2 digits. So again, you could go off to the side, go, hey, what's 12 plus 9? Yeah, 9 plus 2 is 11. Carry the 1. 1 plus 1 is 2. That's 21. But, again, if you're more confident, you don't have to do this side work all the time. 1 plus 5 is 6. 6 plus 6 is 12. 12 plus 9, 21. So notice there's 1 in the tens. Now there's 2 in this next place. So I'm carrying a 2. All right, again, that's 21 tens, which would be 1 tens. And those 21 tens would be exchanged for 2 hundreds. So now I carry a 2. So let's be careful. It's not always 1 if you're doing this larger stacking. If you're only stacking 2 at a time, you'll never have a sum higher than 18, right? 9 plus 9 is the largest you can get, and that's 18. So if you're stacking the 2 at a time like this, you'll never carry a thing other than 1. But if you stack more than 2 like this, you might get higher carries, depending on how many you're stacking. All right, so now in the hundreds place, 2 plus 3 is 5, 5 plus 8 is 13, and 13 plus 5 is 18. So that's 8 here, and then 18 has a 1 in the next place over, so that's 8 hundreds, and then 1,000. Then in the thousands place, 1 plus 1 is 2, 2 plus 8 is 10, so that's 0 here, and then 1 in the next place, and that 1 10,000, then 1 plus 2 is 3. And you see I get exactly the same thing, right? 30,814. Just, again, you got to be careful when you're stacking more than 2 addends, summing more than 2 addends like this, because you may carry something higher than 1, right? But when you're stacking just 2 at a time, you'll never carry higher than 1. All right, so maybe you prefer that. But either way, you get the same result. Let's look at what they're showing us here. So you see how they did the thing where, they stacked them all. That second method I showed you. See how they're carrying the 2 sometimes in that one place? So yeah, they did that second method where they stacked all 3 of them, line up place values, and then, start with the ones and add them up to 30,814. Yeah, so this example had 3 addends. We can add any number of addends using the same process as long as we are careful to line up the place values correctly. Another thing I would say be careful of, right? I mentioned it already, you saw it. If you line up more than 2 addends, you pay attention to what needs to be carried if you need to carry. All right, you may have to, if the sum of the addends, if the sum of the place value is in the 10s, you're carrying a 1. If it's in the 20s, you're carrying a 2. If it's in the 30s, you're carrying a 3, and so on. So just be aware. All right. So then our try it problems, and I'm not going to do both methods, right? I am just going to do that one word because I'm confident about my ability to add strings of numbers. So hopefully you get to practicing enough to where you can too. But I'm going to stack all 3 of them and just be aware that if my sum is in the 20s, I'll be carrying a 2, right? With 3 addends, if you're stacking 3, the largest any column can get is 9 plus 9 plus 9, which would be 27. So the largest you'll carry is a 2. If you're stacking 4 addends, 4 9s would be 36. You could carry 3 then, and so on, right? So just be aware, be very careful. So try it. 1.41. We're adding 46,195 is one of the addends, plus 397. And then again, this plus at the very end here implies that we're doing, now you could have, I guess you could put a plus between all of them. Doesn't matter, as long as you know you're doing nothing but addition. And then the final addend, 6,281. Once again, just be aware of lining up all the correct place values. Let's start with the right one. Let's start with the ones place. 5 plus 7 is 12. 12 plus 1 is 13. So that's 3 ones and 1 10. Right, so 1 goes at the carry a 1 in the tens place. Now these digits in the tens place, 1 plus 9 is 10. 10 plus 9 is 19. And then 19 plus 8 is 27. So it's in the 20s. So I have 7 ones and 7 tens and 2 hundreds. Right, that sum was in the 20s. So I carry a 2 in the next column. All right, now in the hundreds place, 2 plus 1 is 3. 3 plus 3 is 6. 6 plus 2 is 8. That's not that's not 10 or more, so there is no carrying, just 8 hundredths. All right, then in the thousands place, I have 6 and 6. 6 plus 6 is 12, right? So that's 2 thousands, carry the 1 10,000. And then in the 10,000s place, 1 plus 4 is 5, right? So the sum of all 3 of these addends is 52,873. So again, I'm checking chapter 1 answer key, try it. This was try it 1.41. Add them up, 52,873, exactly what I had. Beautiful. And finally, try it 1.42. So another one with 3 addends. I'm going to stack all of them, lining up the place values and adding up the digits, just paying attention to what I need to carry over if the sum is 10 or more, or 20 or more, either one. So try at 1.42. So we're adding 53,762. Add to this 196. And then adding to this 7,458. Make sure all your correct place values are lined up vertically. All right, so starting with the ones, 2 plus 6 is 8. 8 plus 8 is 16. So that's 6 ones and 1 10. Now in the tens, 1 plus 6 is 7. 7 plus 9 is 16. 16 plus 5 is 21. So you have 1 10 and then 2 hundreds, right? Where that sum was 21. So I'm carrying 2 in the hundreds place. Then the hundreds, 2 plus 7 is 9. 9 plus 1 is 10. 10 plus 4 is 14. So you got 4 hundreds with 1,000, just carrying a 1. That sum was only 14. And then the thousands place, 1 plus 3 is 4. 4 plus 7 is 11. So that's in the tens. You got 11, 1,000, and then 1 carrying a 1, 10,000. And then finally in the 10,000s place, 1 plus 5 is 6. So that's 61,416. 61,416. Do one final check here. Let's just try at 1.41. 42, sorry, 1.42. 61,416. Excellent. All right, great. So hopefully you are able to do this addition when you stack up the numbers, stack up the addends vertically, aligning up the correct place values, and then starting from the ones place, you add, and if the sum is in the tens, you carry a 1. If the sum is in the 20s, you'd carry a 2. If the sum is in the 30s, you'd carry a 3, and so on. So be careful. All right. And please, 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 I know I said it already, but get to know all your single digit sums at least, from 0 plus 0 up to 9 plus 9, right, from table 1.1. Definitely know all of those. Great. All right, and so that's it for that heading. The next video, I'll be going through the heading of section 1.2 called Translate Word Phrases to Math Notation. And thank you very much for watching.